All right, so get this, listeners. Today, we're diving deep, deep into the world of AI and 3D modeling, but with a twist.
Uh-huh.
We're not talking about writing lines of code or, messing around with complicated software.
Yeah,
Nope. Today, it's all about just plain describing what you want that 3D model to look like. Simple as that.
you got it.
And then having the AI build it for you. It's like magic, but it's real.
It really is pretty amazing, you know? This research project called LLaMA-Mesh is seriously pushing the limits, like way beyond what we thought was possible with those large language models.
LLMs.
Yeah, LLMs, exactly. And they laid it all out for us in their research paper, LLaMA-Mesh, Unifying 3D Mesh Generation with Language Models.
Okay, so I got to ask, walk me through this. Like, how in the world does an AI, something built on language, go from understanding our words to actually building something in 3D? I mean, this is like a giant leap, doesn't it?
It is. It is. But the key here is all about finding the right way to represent that 3D information. The researchers, they zeroed in on something called the OBJ file format. Think of it like a translator, you know? It takes the shapes and surfaces of a 3D model and turns them into plain text. And that's something the LLM can actually read.
So it's like teaching the AI this whole new language, the language of 3D models.
Bingo. You got it.
That's incredible.
And, you know, it's super fascinating. The LLaMA model they used, it already had some of these spatial reasoning abilities kind of hidden inside, even before they started training it specifically for 3D stuff.
Really?
Yeah, figure 6 in the paper actually shows that it could already spit out some basic OBJ code when they asked it for simple shapes. And this was, like, without that extra training.
Whoa, so there was already a little spark of 3D understanding in there from the get-go. That's wild. But, I mean, to really level up, to get those crazy detailed models, they had to push it further, right?
You're absolutely right. They had to train it, but they did it in a really cool way. They built this whole special data set that paired up text prompts with the matching OBJ code. And they used two main techniques, rule-based, and then this other one, LLM augmented.
Okay, this sounds interesting. So the rule-based part was that starting with the basics, like this is a cube paired with the actual code for a cube.
That's it. Simple as that. Teaching the AI the ABCs of 3D shapes, you could say.
Got it. But what about that LLM augmented part? What's going on there?
No, that's where things get really, really interesting. They actually use the LLaMA-Mesh model, the model itself, to generate more complex dialogues about 3D objects. Imagine it's like having the AI practice by having conversations with itself about these shapes.
Hold on, wait. The AI is like writing its own practice questions?
Pretty much, yeah.
That's mind-blowing. So it's learning from itself as it goes along.
Exactly. And this approach, it created a much richer training experience, way more varied than if they had just done it manually. It exposed LLaMA-Mesh to all sorts of different language patterns and scenarios.
Okay, so now we've got this AI that can build 3D stuff just based on what you tell it. But, I mean, it comes from a language model, right?
Yeah.
So does that mean it can still hold a conversation?
Right.
Or is it just all about 3D models now?
That's what's so cool about LLaMA-Mesh. It doesn't lose those language abilities, those strong language abilities of the original LLaMA model.
Really?
Yeah, figure 7, they highlight it there. It shows how it can still engage in these really nuanced conversations, understand instructions, all that good stuff.
So it's like this double threat. It's a 3D artist, but also a conversationalist all in one.
I like that double threat. That's a great way to put it.
It's pretty impressive, right?
Super impressive. And they didn't just want to say it, they actually tested it. They compared it to other models on those standard language tasks, and the results are right there in Table 3. It held up just fine.
So it's not sacrificing its language skills to do all this amazing 3D stuff. That's good to know. But, I got to ask, what about the models themselves? Like, what kind of things can LLaMA-Mesh actually create? Give us some examples.
Oh, they've got a whole gallery of models in Figure 3. There's so much variety. Cars, chairs, animals. They even made abstract sculptures. And the detail, the complexity, it's really impressive, especially when you think about it. It's all generated from just text prompts.
I'm looking at Figure 3 now. And yeah, wow, these are intricate. I see textures, curves. It's not just basic shapes at all.
You got it. And they didn't want to just make pretty pictures. They made sure the models actually follow real geometric principles. So they're functional. They could be used in real-world applications, not just for art.
So we're talking video games, maybe VR, even product design down the line.
Absolutely. It opens up a ton of possibilities.
This is exciting stuff.
It is. But what I find even more interesting is this. LLaMA-Mesh can generate multiple, totally distinct designs from the same prompt. And they showed this off in Figure 10.
Wait, really?
Yeah.
So it's not just a one-and-done kind of thing. It gives you options.
Yeah, they gave it the prompt 3D model of a wooden pallet, and it came up with 3 different designs, completely different, each one with its own unique shape and structure. And they have similar examples for trash cans and chairs, too.
So as the designer, I could give it my idea and then actually browse through different options to see what works best.
You got it.
That's amazing. It changes the whole game.
It does, it does. It's like having a whole team of designers brainstorming different takes on your concept. And that ability to explore different variations, it's crucial for anything creative.
This is seriously making me rethink what AI can do.
Mm.
But how does LLaMA-Mesh stack up against other 3D modeling methods out there? There's some pretty sophisticated stuff already, right?
Oh yeah, there's some tough competition. They actually compared LLaMA-Mesh to models like Mesh XL and Unique 3D. Figure 11 shows it's right up there with them in terms of detail and complexity.
So it's holding its own against the big players. That's impressive.
It really is. And here's the kicker. It does all of this. The 3D modeling, the language skills, the variety. And it does it all while being super efficient in its training. They break down the numbers in Table 2, and compared to something like Mesh XL, LLaMA-Mesh uses a fraction of the time and resources to get similar results.
So it's not just better, it's faster too. That's a win-win.
Absolutely a win-win. And that efficiency, it all comes back to that powerful pre-trained llama model they started with. It's like they gave it this head start right out of the gate.
This is seriously cool stuff. It's like the AI equivalent of a multi-talented overachiever.
Ah, that's a good one. Yeah, kind of is. But even with all this amazing progress, they're not done yet. The paper, it outlines a whole roadmap of future developments. And that's what we're going to dive into in part 2 of our deep dive.
Okay, you've got me hooked. Can't wait to hear about those. Until then, listeners, you can ponder all the amazing things LLaMA-Mesh can already do and imagine what's next.
We'll see you all in part 2. Welcome back, everyone. Let's jump right back into our exploration of LLaMA-Mesh.
I'm ready for more. Last time, we were blown away by how efficient this thing is. Remember, way less time and resources than other methods.
It's true. And that efficiency all boils down to, well, leveraging the power of that base llama model. But as with any new technology, there are always areas where things can be improved.
That's true with everything, I guess. So what are some of the limitations they talk about in the paper?
Okay, so one they highlight is something called vertex quantization. Remember those OBJ files, how they, represent the 3D model as text?
Yeah, it's like the translator for 3D.
Right, right. But to make that work, to make that translation happen, the coordinates of each point in the model, each vertex, they have to be rounded off to fit into like a limited number of categories.
So it's kind of like compressing the information. Makes it easier for the AI to handle.
Exactly. You got it. But there's a little trade-off there. That compression, it means you lose some of the finer details, and this can impact the precision of the models, especially when you're dealing with those really complex shapes.
Makes sense. It's like when you reduce the resolution of an image.
Yeah.
You gain some speed, but you lose some of that sharpness.
Right. And the researchers, they acknowledge this. It's a trade-off. They suggest that future work could focus on finding, better ways to encode that 3D information, ways to get higher precision without sacrificing that efficiency.
It's always that balancing act, isn't it?
Well,
accuracy versus speed.
Always. Another limitation they bring up, it's tied to the nature of language models themselves. LLaMA-Mesh, like any LLM, it has a limited context length. There's a cap on how much information it can process all at once.
Okay.
And this can become a problem when you're trying to generate those really, really large or intricate 3D structures.
So it's like having a word limit, but for 3D shapes.
That's a good way to put it. Yeah, a word limit for shapes.
Mm.
They suggest that developing techniques to handle longer sequences of information, that would be key to, really unlocking LLaMA-Mesh's full potential. Let it create those even more complex designs.
It's like giving the AI a bigger canvas to work with, more space to be creative.
Exactly. Precisely. All right, so let's shift gears for a moment. Let's talk about the future.
Okay, now we're talking. What kind of exciting stuff are they envisioning?
Well, imagine this. You could design your dream home just by talking to your AI assistant. You describe each room, the furniture, the lighting, everything. And it just generates a 3D model that captures your vision perfectly.
Wow, okay. Sign me up for that. That would make renovations so much easier.
Right. And it doesn't stop there. They talk about revolutionizing video game development,
Right.
making it super easy to create those complex worlds and characters. They even mention using it to, improve product design or even bring educational concepts to life through these interactive 3D simulations.
This is starting to sound like, I don't know, science fiction.
I know it does, but it really highlights the potential here. LLaMA-Mesh could completely reshape the way we create, the way we interact with, and even the way we understand 3D objects.
It's really mind-blowing when you think about all the possibilities.
It really is. But for now, let's bring it back down to earth a little. Let's get back to the research. There's one more really crucial aspect we need to explore, and that's LLaMA-Mesh's ability to actually understand and describe existing 3D models.
Oh, hold on. So it's not just a builder. It can actually analyze 3D models too.
That's right.
That's like a whole other level. That's incredible.
It is. And that's where we'll pick up in part 3 of our deep dive.
Okay, now I'm really intrigued. Can't wait to hear more about that. Until then, listeners, you can ponder all the amazing things we've learned about LLaMA-Mesh and let your imaginations run wild.
We'll see you all in part 3.
Okay, so we're back and ready for the grand finale of our LLaMA-Mesh deep dive.
And we've definitely saved the most mind-blowing part for last. We talked about how it can create these amazing 3D models straight from text, right? And how incredibly efficient it is, even some of the limitations it has. But now we're getting into something truly unique. LLaMA-Mesh's ability to actually understand and describe existing 3D models.
You mentioned this a bit in the last part, and honestly, I'm still trying to wrap my head around it. It's like this AI can not only build things, but can also analyze and explain what it's seeing in 3D.
Exactly. You got it. It's like imagine having an AI art critic, one that can look at a sculpture and not only tell you what it is, but also give you insights into its structure, its purpose, even its historical significance.
Okay, yeah, that's pretty wild.
Yeah.
But how do you even start teaching an AI to do that? 3D models are so complex.
Well, it all circles back to that idea of representation. It's about finding the right way to bridge that gap between the visual world of 3D and the language-based world of AI. And they did this by using a similar approach to the training we discussed for the mesh generation, that combination of rule-based and LLM-augmented techniques.
So they start with the basics, like teaching it a 3D vocabulary.
Yeah. That's a great way to put it. They paired simple 3D meshes with, straightforward descriptions. Like, for instance, a cube might be paired with the description, this is a 3D model of a cube.
Like the building blocks of 3D understanding.
Exactly. And then they went a step further with that LLM augmented approach. They used LLaMA-Mesh, the model itself, to generate more complex dialogues. So they created these sample conversations where the AI would, describe different 3D models and then use those dialogues to train it further.
So it's like it's learning by example, but the examples are coming from itself. That's some next level AI stuff right there.
I know, it's pretty amazing. And the results! They're remarkable. Figure 7 in the paper, they show off some of LLaMA-Mesh's mesh understanding capabilities.
All right, let's see what this thing can do. What kind of descriptions are we talking about?
Okay, so in one example, they gave it a 3D model of a wooden barrel.
Okay, a barrel.
And LLaMA-Mesh, it describes it as, this is a wooden barrel. Barrels have been used for centuries to store and transport goods, from wine and oil to grains and other commodities. They're often made of wood, like this one, and come in various shapes and sizes.
Wow, that's incredible. It's not just recognizing the shape, it's understanding the function, even a little bit of the history.
I know, it's amazing, right? And in another example, they give it a 3D model of a metal trash can.
Okay.
And LLaMA-Mesh, it nails it, describing its purpose perfectly. The primary function of a trash can is to collect and store waste, keeping it separate from other items and preventing litter.
So it's not just saying what it sees, it's understanding the why behind the object.
You got it. And this ability to understand and communicate about these 3D structures, it just opens up a whole universe of possibilities. Think about how useful this could be for architects, designers, really anyone working with 3D models.
It's true. They could have this AI assistant that can analyze their designs, provide feedback, maybe even suggest improvements.
Absolutely. It could completely revolutionize the way we collaborate and communicate in those fields.
This whole deep dive, it's been mind-blowing, honestly. LLaMA-Mesh, it's groundbreaking stuff. It's not just about 3D modeling. It's about bridging that gap between human language and the world of 3D. It can create, it can analyze, it can explain.
It really represents a giant leap forward for AI, and it opens up so many exciting possibilities for the future. But as with any powerful technology, it's crucial that we, continue to research, explore, and develop it responsibly.
I couldn't agree more. Well, listeners, this brings us to the end of our deep dive into LLaMA-Mesh. Thanks for joining us on this incredible journey. We hope you've enjoyed exploring this fascinating new technology with us.
And as always, we encourage you to check out the research paper yourselves if you want to go even deeper down the rabbit hole.
Until next time, keep exploring, keep learning, and keep those imaginations firing. We'll see you on our next deep dive.